In case you haven't figured out how to graph sine, cosine, tangent on your calculator, I want to take a moment to show you how to do that. The first thing you have to do is make sure that you change your mode. So push mode on your calculator. And when you go down, you have the choice between radians and degrees. Whenever you're graphing, you'll want to choose radians. Now, when you get ready to take the ACT, you'll want to make sure that you put your calculator back on degrees because the calculator has most of the questions. In fact, I think all of the questions are in terms of degrees. So, but for now, we want to look and see what the graph looks like. So I'm going to go over and push radians. And then I'm going to go to y equals. So to graph the tangent graph then, I'm going to push tangent of x and hit graph. And you can see that this looks just like what we did on our calculator. And we had a graph going through pi, and notice how the x-axis is labeled here. It's still going by ones, but we know that on our graph we did earlier, the graph went through pi. So if we're going in terms of radians, pi is the same thing as 3.14. So you can see how it goes through 1, 2, 3.14 right there. But what I want us to talk about next, and so I've kind of still got my graph from before on here, and we'll use our graphing calculator. But what happens if I want to graph tangent of x divided by 2? So in this particular case, what's happened is we're changing the period. Because if the tangent, x over 2, so we put a number inside here with the x. If the number was on the outside, it would have just stretched this graph vertically. But tangent x over 2 is going to change the period. So with sine and cosine, we always did 2 pi over b. But tangent is different. We don't use 2 pi. The period of tangent is just pi. So if I want to find the period of x over 2, that's the same thing as tangent 1/2 x. So the b in this case is 1/2. So since period for tangent is pi, we're going to do pi divided by 1/2, which is flip it and multiply, would just be 2 pi. So tangent of pi over 2 would be 2 pi. So what's going to happen then is this thing is going to stretch out. So here it was pi units long. So now it's got to go from here to here to graph. So it's just really going to widen this because the period is wider. So let's type that in our graphing calculator and take a look. And if you don't have a graphing calculator at home, that's fine. You can do this in the Desmos graphing calculator to experiment. So I'm going to go back to tangent, and I'm going to put in tangent of x divided by 2 for the second one, and this should stretch horizontally, or compress vertically would be the same way to say that. So you can see how now this really elongates out through here because the period has been stretched out. So let's go back and think about what would happen then if instead this was, if it was not x divided by 2, let's say it was tangent 6x. What would happen in this case? Well, normally our period is pi, but now a period is going to be pi over 6. So we're going to have a whole bunch of tangents if the period is pi over 6. Let's look. So there's the one that's just tangent. And here's tangent 6x. You see how there are more of them because the period is smaller. Kind of fills in pretty fast. Let's go back and let's clear that. And let's think about what would happen then if I changed my tangent graph. And this time, what happens if I put a 5 in front of the tangent? What should happen here? Yeah, the 5 should make this thing stretch vertically. So let's take a look and see. There's tangent. And here's 5 tangent. So you can see how each one is actually, we can say steeper, even though steep really goes with linear, but it really stretches it vertically. It takes the graph and pulls it vertically.